Hey guys, let's finish that problem from class that we didn't have time for. It was the parabola y equals 2x, and the point was 1, 4, and we had to find the point on this parabola that's closest to that point. So let's get a good picture here. After a little bit of debate, we figured out that the parabola opens this way. It looks something like this, and 1, 4 was somewhere up here. And somewhere on this curve is going to be the closest point. So let's just guess it's like, let's just say it's here. Okay, we don't know for sure where it is at the moment. But this distance is going to have to be at a minimum if that's going to be the closest point. That's what we ended up settling on. So if we call this point xy, well then the distance from 1, 4 to xy would be y minus 4 squared plus x minus 1 squared and square root of the whole thing. And then one of the little hints I gave in class was instead of having to deal with this square root, we're like, can't we just call this d squared, basically do a Pythagorean theorem problem? Just make the algebra and the calculus, derivatives a little bit easier. So we settled on this, and I think that's about where we left off. We talked about substituting, but we never actually got to that point together. So I think I'd like to do that now. So I could solve for y, but then I got to deal with a square root. I mean, it certainly will work. But it probably is easier if I solve this for x. So this is going to be x equals 1/2 y squared. So d squared is going to be y minus 4 squared plus 1/2 y squared, minus 1 squared. Right? So x is replaced with 1/2 y squared. There's my 1/2 y squared minus 1 and then quantity squared. And at this point, you probably could just take the derivative. You could expand these out. I guess they're not that bad. Either way, in all honesty, it's probably the same amount of work both ways. So this is going to be 2d d prime equals 2y minus 4 to the first times the derivative of y is just 1. Remember, we chose to do it with respect to y, so you don't need a dy dx as a chain rule kicker for this. We could have done it with x, and it would have been the same idea. So plus this is going to be 2 1/2 y squared minus 1 to the first times the chain rule kicker here. I got to do 2 times 1/2, of course, is 1, so this is just going to turn into y. And let's clean that up a little bit. 2d d prime, so this is going to be 2y minus 8 plus 2 times the 1/2 cancels. Y times y squared is y cubed. 2 minus 2y. I think that's all the pieces. And so 2d d prime equals anything I can put here. The 2 y's cancel. That's convenient. So negative 8 plus y cubed. Okay. Let's solve for d prime. Negative 8 plus y cubed over 2d. Now at this point you might be looking and saying, okay, how do I deal with this 2d? I don't really care about the 2d, to be perfectly honest. I'm looking for critical values. Okay, so the only critical values occur when the derivative is 0 or undefined. The only way this is 0 or undefined is if d is 0. That doesn't help me. I don't want the distance to be 0. That's kind of, that doesn't really make sense in the context of the problem. So the only thing I really care about is when is this numerator 0. That's the only critical value that's going to be of any use to me. So when is negative 8 plus y cubed equal to 0? Well, that's when y cubed equals 8, and that's when y equals 2. If y equals 2, then x equals 2. So the point in question must be 2, 2. So this must be 2, 2, and that gives me the minimum distance. Okay? You could do the number line, with 2 and check the value out, and you'll see that the slope goes from, negative to positive, okay, to get a minimum. But that's basically the end of that problem. Okay? Hopefully you were getting there on your own anyway. If you did try to do the square root of 2x, you should have gotten the same thing. If you want to put that in the calculator, once you get your derivative, you would have seen the same thing. But that's basically it. Okay? All right. I'm actually going to upload this separately, and then I'll make a separate video for the last one in case anybody needs that. Okay? Let me know if you have any questions.